the LCR series and LCR parallel, when you revise, it is better to see in a comparative manner. For example, in LCR series, if you see the source is inside the circuit, here in LCR parallel, the source is outside the LC circuit. And the current expression here is that current is maximum, and in case of LCR parallel, the current is minimum. The impedance is minimum in case of LCR series, and the impedance is maximum in case of LCR parallel. The resonant frequency in case of series is f0 is equal to 1 upon 2 pi square root of LC, and in case of resonant frequency of LCR parallel, it is f0 is equal to 1 upon 2 pi square root of within bracket 1 by LC minus R square by L square. And if you see, there is no such condition in case of LCR series resonance, and in case of parallel you have a condition for resonance, that is whenever the resistance must be very less than that of square root of L by C, then only you will get the resonance. And in case of LCR series, it acts as the LCR series acts as an acceptor or a selector circuit, but in case of LCR parallel, it acts as a rejector circuits. And if you see to the quality of LCR series, which is equal to omega 0 L upon R, which is equal to 1 upon omega 0 RC, that must be equal to 1 upon R times square root of LC. But in case of your parallel, you have omega 0 RC, which is equal to R upon omega 0 L, that is equal to R times square root of C by L for ideal LCR parallel circuit. And if it is a case of real LCR parallel circuit, then we have to replace the resistance by R equivalent, that is equivalent resistance, and the inductance, that is L, has to be replaced with parallel inductance LP using the series to parallel conversion formula. And the bandwidth in case of LCR series is the resonant frequency upon the QS, that is quality factors, and in case of your LCR parallel, the bandwidth is only defined as at resonance, that is equal to f0 by q parallel. And if you see to the diagrams, that is below the resonant frequency, the LCR series circuit is effectively behaves as capacitive one, and above the resonant frequency, the LCR series circuit effectively behaves as an inductive circuit. But in case of LCR parallel, below the resonant frequency, the LCR parallel circuit effectively behaves as a inductive case, which is the reverse case of that of LCR series, and above the resonant frequency, this LCR parallel circuit effectively behaves as a capacitive circuit, which is again opposite to that of your LCR series circuit. Now, if you compare to that of your LCR series and parallel, the LCR series behaves as a voltage magnifications at resonance, but LCR series behaves as a current magnifications at resonance. And the corresponding examples we can see for a LCR series with AC EMF of 140 volt, frequency 50 Hz, inductance is equal to 0.2025 Henry, capacitance is equal to 50 microfarad, resistance is equal to 0.2 ohm. The potential drops across the inductor, which is same as the potential drops across the capacitor, that is equal to 44,540 volt, which is extremely high over the source EMF, which is 140 volt. And that is the reason why we call it as voltage magnification circuit. And in case of a LCR parallel circuit, if you see, that is for a LCR parallel circuit with AC EMF of 2 volt, let us say, with frequency 50 Hz of course, and inductance 2 millihenry, capacitance is equal to 0.001 microfarad, resistance is equal to 15 ohm, the ratio of peak of oscillatory current to peak of the makeup current, which is equal to IC by I0, which is same equal to IL by I0, that is equal to 94. And hence, it shows that the oscillatory current is magnified over the makeup current, and that is the reason why we call it as current magnifications at resonance. And if you compare to LCR series and LCR parallel, there is difference of resistance. For example, in case of LCR series, it behaves as a low resistance for the source, and in case of a LCR parallel, it must be a high resistive path at resonance, as we have seen. But effectively, we can check that R equal to 0 is the condition for which both the LCR series and LCR parallel behaves in the same manner. Thank you.